Still we have to make the design, so we have to define the sample and so on, so because we are precise people. So our sample will be USD Euro exchange rate, because we are located in France, so that's why we have to denominate everything in euros, so this is the right direction. And also I would like to make a simple model, so nothing fancy, just we have to take also the sovereign spread. You remember from international finance when we were talking about the uncovered interest rate parity. And this is not bold. So sovereign spread, so we will see that how the difference between the US, let's say R flat line, epsilon US, and practically we can use this as an equation, so or we are a French company, so let's use French. I never used French indicators, so it will be a surprise for me as well. And for the simulations, we need weekly data. Because for simulations we need lots of data to calibrate the GARCH model, and for the macro model we need quarterly data. So before data acquisition we have to not forget about this issue. And we can ask the question that what is the sample size in this case, or what is the length of the time period. We know that okay, we need 30 data points, so if you are above it a bit, it's no problem for us. So let's start it in 2010, and then it will continue until 2022. It should be sufficient for us. Yeah. And of course, data source. We could use Toku because it's free, but also since we have just the usual warning messages and chart. And loading. And then we have to define then USD Euro. Okay. Then with the 10-year US. Do we have Euro? Yes, we have only swap. Oh, come on. Then we have French. Yep. But also we could let's add inflation as well, because maybe it has an added value. Inflation US. Yes. And also yeah, because it's not daily, it's quarterly. Yeah. Okay, now it's able to cooperate. And okay, so let's add it as well. So So we got inflation. We could add also central bank balance sheet, but no, let's stop it here. So, and let's define the time range. So we need everything from 2010, January 1st, until today. So we have all this nice quarter of years, so we just have to download this International Financial Management FX rate. And now it's much more beautiful. Also, we have to remove this close. Short, oldest to newest. And now, still we have to save it because otherwise it will be really hard to work with it and upload it to you on CodeSpace. So, yeah. Okay, so data preparation is done. And until you are opening it, I just create a nice sheet of information about this. Just housekeeping until you are downloading the data. So. And we can see that this is how it's look like, and maybe some coloring. Yeah. So, first question is obviously, so what is the historical trend here? Historical trend in the data. We can say that it's not doing anything at all, but still we have to make it more sophisticated reasoning. So let's move it maybe here. And let's fit a linear trend line. So this is the lowest effort, but a trend line, linear, and display equation in chart. R square also we can add it, it's free. So if we are looking on it, then we can see that the R square suggests that it's completely useless because this is far away from the 100%, so it's 60% at most about the accuracy. And also what we can see here that it's actually the steepness is positive, so it's depreciating. Oh, come on. However, the R square is too low. So, right now we can see that questioning against the US dollar on the long run. So, first method detected, possibility of further depreciation. So, let's see the next or solution, which will be simulation. Simulation of the data with a GARCH model. Yeah, so if you would like to do a simulation, first of all we have to describe that what is a GARCH model at least. So GARCH model will provide us the parameters which will describe the conditional volatility. So it's conditional because it changes in time, so it's the mathematical term for that, this phenomenon. Volatility, persistence means that volatility on previous days okay, now we are using weekly, so previous weeks has an influence on today's volatility. And this will be significant. Okay. So now I think it's, yeah, I should save it also. Documents. Why the document is empty? Oh no. What happened here? Because I'm in English mode, so and only custom office templates are here. Come on, Marty! Where is my Matlab? Oh. There is no Matlab on this computer now. Just yesterday I was using it, so it's supposed to be here. Okay, so okay, so it's working. Just it was never used. So first I would like to ask everybody to open Matlab. So if you are typing here Matlab, then you will find it there. And once you are opening it, then we will talk about at least we have the toolbox here. Okay, you are able to open it. Okay, cool. Then, next thing I would like to ask you, since nothing is here what's supposed to be, then if you are in the code space and in the case study folder, then please download this mfa toolbox.zip into the documents Matlab folder. So here. So this thing should go here in the documents Matlab folder. And if we are clicking on it, then extract all. Okay. Yeah, we have it. So you should download this to here documents Matlab, and then with the right click you should click on extract all, and then okay, and it will be there, because this is you are not burning. Okay, so this is an external toolbox which was developed by a guy called Kevin Sheppard. He's a professor at Oxford University, and this database or this Matlab toolbox is way better than the official Matlab toolbox, so that's why we will work with this. Can you smell some heated plastic?
Yeah.
It's faster to open the window, maybe.
Yes, just okay. If there is a fire, then sooner or later we will see it. So we're opening the window.
你真棒，今天。扇子。
咋了？你要这样下吗？
Yeah. Okay, so now if you are looking on Matlab, then we can see this structure. So here we have the current folder with all the contents of the documents and Matlab folder. Now we can see, since we extracted the MFA toolbox folder here, these are the details. We don't care about it, so we can off. Then this is the editor. If you don't have editor, then you just have to click here at home, new script, and then you will have it. So home, new script, and then we'll find it. In the editor, we will write the code. So this is where all the coding is happening. In the command window, we will get messages from the software, and also error messages. So all the communication with the software is happening here from the side of the computer towards us. And this is the workspace. This is where all the data will be loaded in. So at the end of today's class, I will upload the code on the code space. So if you are not able to follow sometimes, or there is a mistake, also you should put your hands up and I will help. But at the end of the day, I will upload the appropriate version of the code. Yeah. So first of all, we should start writing. And before doing that, we should check the preferences, because maybe for you it's good, but for me it will be not good, because the font size is 10 and you are not able to see this from the distance, so that's why I have to increase this. Yeah, now I can do it. Okay, so in
我还是搜不到这个，用了这个。
天哪，把解完，指标跟不上。
Then it's chocolate milk time. Okay, so Everything is okay now. Okay. So when we are writing codes, obviously you need documentation. And that's why we are using these percentage marks. So with Shift 5, we can write, if you are writing 2 of them, then it will be bold, so we can see that International Financial Management. So, comma? Yeah. Okay, so it's here.
5.
Okay, so first point or 0 step is always loading the data. So we will write our first function here. So in the case of functions in Matlab, there is always the following structure. So there are the outputs in a squared bracket, which is RGRF and RGRG. So and then there is an equation mark, and there is the function name, and behind it there is an usual bracket, and there are the inputs. So the structure is always the same. So on the left side we can find the output, there is the function name, and there are the inputs. So after that it depends on the actual function name, that what kind of inputs and what kind of outputs are they providing us, but the structure is always remaining. And in case we are not sure that what kind of input do we need, yeah, if you are looking for ordinary brackets, ordinary bracket opens with Shift plus 8. And closes with Shift plus 9. And oh, what is this thing? It's semicolon?
Yes.
Yes, semicolon. So it's RGR plus ordinary colon. Just to put here everything that. Okay, so our first job is to read in the Excel sheet, and in this case, let's assume that I have no idea how to do it because I'm not doing it in every week. So and if I'm writing in Excel, then you can see that the entire handbook is coded in the Matlab. So you can find all the functions, all the examples, even tutorials, not just in the internal help menu, but also with Google. So it's open for outside as well. So we can see that, oh, Excel, and the fourth thing is Xls Read Function. Okay, it said it's not recommended, but who cares? It's working completely well. So yeah, if I'm clicking on it, then I can see that Xls Read will be your friend because it reads in stuff. And also we can find not just the file name, but also the sheet name, even the range, but I never use this, so it will be perfect. So right now I should define the file name, so it's, let's say it's located here. What is your name? So this is the location for the file. And we need the weekly sheet. I hope it's weekly. Yes, it's weekly. And then here we can say that data. And we should use the semicolons because in this case it will not write out all the contents, because it can slow down our code. So let's stop here, so I will continue with you. So first of all, can you see this font size, or should I increase it further? You can see it. Okay. So square bracket opens, data square bracket closes, then equation mark, Xls read, bracket opens, then there is this upper comma with shift 1, and you can see that it has this nice pink or purple color because it's a text, and that's why we have to put it between this upper commas. And also we can see that this is the sheet name, so weekly, it's also between upper commas, and yeah, bracket closes, and that's all. And if we are highlighting this thing and pushing F9, so F9 is always about to run the script, or if you are right-clicking on it and evaluate selection, that it will do the same thing. So sooner or later we will find here data matrix in workspace, and if you are double-clicking on it, then we can see that yes, there is something. So we can plot this out. And we can see that we have something which looks like a US dollar euro exchange rate. Okay, are you ready? Yeah, at the beginning you have to remember so many things, but usually it takes 1 or 2 classes to get used to Matlab, because at the beginning it's always shocking for students. It was also shocking for me as well, so it's like car driving or ice skating or yeah, something like this one. You have to learn many things in a short time. So welcome to Central European Keyboard. This is the same in Germany and in Czechia and also in Hungary, with this completely different setup of special keys. Okay? Okay, best of you. Okay. Okay.
先背景部分，先分空间。等我读完之后，
Good. So, next thing is to start to use. Oh no, sorry, we have to prepare first the data. So we need logarithm. No, just simple changes of the data. So we have to differentiate it. So we are using this diff data. Usually we are also logarithmizing it, but right now it will be much easier for us to reconstruct. So return is just added. This diff just takes each day's difference, so today's minus yesterday's, then yesterday's minus the day before, and so on. So this will give us something like this. So we can see the movement was increasing or decreasing, and its expected value is really close to 0. So now we can use it for any statistical purposes. Before of that, the raw data set would be absolutely useless. Okay, so now we can start to play with this. So that's why we have the MFA toolbox. So we have to click on it, and we can define that CD. And also we should say that first point is GARCH model fitting. Today we will just fit a simple GARCH model because US dollar, euro are the best behaving currency. So they are really close to efficient market. I can't say that they are efficient, but according to their statistical properties, they are way better than emerging currencies, for example. So we have to use the touch function. This is a really long function, so I will shorten it for you, and it will be way easier. So we have parameters, the log likelihood, and practically the HT. This is what we are looking for, because parameter is whatever. Let's copy it. So parameters will contain us the alpha and beta parameters of the GARCH model, and the HT. The H should be supposed to be rho, or sorry, not rho, sigma in Greek alphabet, but in Latin alphabet it's H. So this is the time variant or conditional variance. That's right, it changes in time. So let's see. So these are the outputs, and then also we should define the inputs because this is relevant for us. So first of all, the Matlab is focusing on the location of the different inputs or outputs. So I can rename it, it doesn't matter, but I cannot change their location inside the code. So I can say that I don't want to care about epsilon variable because already I have read the return. we have P, O, Q variables. So let's say P equals 1. So previous weeks shock will be added. The O, let's turn it to 0. So we don't want to complicate things right now. So this is variance, or let's say volatility, is not increasing more if or under depreciation. If it would be 1, then it would be asymmetric. So right now it's a symmetric model. Then still we can see that we have Q. Q equals 1. So previous weeks volatility will be added. And still we have one thing to do, error type. It can be normal distributed, but we know that market is absolutely not normal distributed. Even the US dollar euro exchange rate, it's far away from this level. So we are digging up some fancy thing, and this will be student T distribution. So it's a fat tail distribution, so it allows much more extreme data than it could happen under normal distribution. So it allows us to have sometimes a financial turmoil and stress on the market. Because it generates way more extreme. And now we can see we defined everybody. So let's run it. And if we did it well, then we can put the HT So GARCH models are widely used, so we will use them also for option pricing, and it can be used also for diversification strategies. It can be used also for the assumption of CAP and beta. So there are many different applications. Today we're just using it for simulation, but we can see that yes, the volatility of the US dollar euro exchange rate changes in time. So we can see that sometimes this volatility is really low, so the market is quite sure about the pricing of this currency pair, and sometimes it's absolutely stressed out and not able to do anything, but after that it comes back again. So this phenomenon, when we can see that there are high volatility and low volatility periods, this is called as heteroscedasticity. And also we can see that these periods are quite stable, so the volatility is persistent. So once it's high enough, then it stays there for several weeks until it's coming back again. So, okay? Not okay? Should I go there? Yes. Okay. Your code is.
这怎么那么黄黄的呀？
有真题，那你可以去后面给我讲第二次作业怎么写。
So we can see that sometimes even key currency pairs can be crazy. So after that, let's see simulation. And also, let's check the parameters. So what are the parameters? So if we are clicking on it, yeah, then you cannot see it. So I will just create a bar graph from that one. It's still okay. It's utterly useless. So this. The first would be the constant, the value of the constant, which is always 0, so it doesn't matter. The second is the alpha parameter, and it's usually around 10%. Yeah, it's 9.99%. And the third thing is the beta parameter, so we can see it's 88%. So we can see that previous week's volatility had 88% importance in today's volatility, so yeah, it remembers. And this last thing is just a parameter of the student distribution, so we don't care about this one. If it has a certain value, then it would be normal distributed, but I never remember the threshold, so yes. Yeah. So it's written here somewhere that maybe it was 5 or something like this, then you can convert. No? Oh, whatever. So it's practically it's not normal distributed. Yeah. So simulation, because this is what we are looking for. So there is another function here called GARCH-simulate. Also, we will just collect the pieces that are necessary for us. We already defined the P, O, and Q parameters, the error type. We don't need the touch type because it's default. And if we are clicking on it, we can see that these parameters appeared already, so they are defined. It's really useful because we can check that we have the ingredients except the T. So this is the length of the time series what we would like to simulate. So let's say that T equals, we would like to see a year ahead or 5 years ahead. Let's see 5 years ahead. So 5 multiplies 52, and in this case we can see that lang of the simulated data. Okay, it would simulate also volatility, but I don't care about volatility right now. We just need simulated data, so let's run this. And if we are plotting this simulated data, then we can see that, yeah, it's doing something. But still we have to connect because still it's the changes. So what we simulated here is just the possible changes of the data set. So we have to connect this with the existing data. So let's say that same data 1 1 equals data and 1. So in Matlab, and I also have to write it what is happening here, so let's connect the simulated changes of the foreign exchange rate to the last known value. So we know that the last known value was at the last row. So in Matlab we are always defining points inside a table or matrix like row and column. A row and column structure. So if I'm saying that this is the end, so it means that the last row, but also this row parameter or column parameter can be a number, it can be a range, so 4 till 7, it can be and, obviously, as you're able to see it, or it can be I, so it can be a letter which will be defined later or externally, and yeah, and also it can be everything. So this is and in the columns we have the same thing, just there we can, I'm using always J, so that's the difference in the notation. So we are defining a new variable where the first row will be coming from the data, so we can see that, oh, last time we measured this, it was, or last week it was just 1 and some zeros in the euro exchange rate. Then what we have to do here is, okay, next thing equals this value plus the simulated data's first row, this was that. So if you're adding them together, we can see that this will be the new simulated, or the first simulated value, so we can see it. And of course, we could define the third line by increasing the numbers here, but it would require so many time to do all these things for how many times? Yeah, 260 times. So obviously I'm too lazy for that. So that's why we have 4 cycles. So in the case of a 4 cycle, we can say that, oh, that I will define an I, which will have the value of 1, 2, 3, 4, and so on until reaching the level of t, because this t is 260. And then I just can say that, okay, if it's 1, okay, let's copy this here because it will be maybe less confusing if I'm doing it this way. Then we just have to follow the rules. So this one is I. Let's assume that I is 1. Then this is I plus 1. And this is just also 1. And then we can see that, oh, what is happening if I it's 2. What was I doing here? Yeah, this is wrong here. So what is happening if I it's 2, then we would see the same thing, so we can eliminate them. and we have to write an end for it. And if we are executing it, then it will generate us a happy simulated exchange rate. Obviously it have to be different than yours because this is simulation, so it will change from running to running, but right now I can see that this is one possible outcome. So now we did this once, but obviously it's not enough to have one simulation, so we need at least 100. Okay, last time when we were talking about this with the dean, he told us that, yeah, but 1000 is much more efficient, but it's way easier to manage 100 because in this case, if we are selecting the 5% quantiles, then it will be automatically the 5% of quantiles. So for me, from data management point of view, or for coding point of view, it's way easier to do so, and the accuracy will not change that much. Or the problem that we were talking about, it required several hours to run, so even for 100, so 1000 would require a week or I don't know what. But in this case, at this scale, still we can say that let's do this for several times. So for j 1 to 100, and you don't have to be afraid if you are not able to follow this. I'm recording the video, so I will upload it, and you can watch it back if you are interested in it. So, okay, so we have a big for cycle, which contains all the simulation, and still we have to teach this thing. Let's say that we will extend this sim data further and further, so it's not 1 anymore, it's j, you are also j. So it's not a vector anymore, it will be a matrix with the parallel simulations again and again, and we can see stuff happening. So if I'm plotting this right now, then we should have something like this. So this is today, and then we can split it to different pieces to see that what are the possible outcomes for euro and US dollar. And we can see that, okay, at this alternate timeline, we would have really strange movements, but also here as well, so these are the extremities. What is happening in the middle, these are usually the expected values. So let's have the evaluation of the possible scenarios. So we have our simulation here, and after that we just have to collect what is happening in the different years. So let's say that output okay, first let's keep it simple. So and let's define it backwards. So what is the expected value here? So the expected value here will be the mode of the sim data. But we would like to see what is expected 5 years later, so we have to say that this number here and all the simulations. Oh. Oh. But why? Maybe not the mode should be. Median. Okay, it's much more realistic. Okay, so let's use median. And then we have this output function or output matrix which will connect or collect these things. And let's say this will be in the second row, first column. And then let's have the optimistic scenario. This will be in the first. But now we need the quantiles. No, quantile. So this is the function how it's supposed to look like. So we should create, it's called quantile. We have the data here, so this is the x, and we need the p, so let's define it 0.05. And also we should see the other quantile, the pessimistic. This will be the third, 95 quantile. Yes. And now we can say that, okay, if we were able to build this for the last year, then we can practically do this for each years by a well-defined for cycle again. For j equals 1 to 5. And because just we have to add that, okay, this is not 1 anymore, it's j. This is also not 5 anymore, it's just j. And hopefully I did not mess up anything. And we can have a bar diagram on it, and this will be the peak point of today's class, because finally we have yes, possible exchange rates for hello. So we have possible exchange rates for all the years. So we can see that for the first year, so this is the median scenario, this is the optimistic, and this is the pessimistic scenario. So valuation technique or other things with such data. But obviously it will change from running to running, so if I redo the simulation again, this will change a bit. So just to be sure, so we can see that, okay, it still suggests that there is a depreciation and there is an appreciation happening, so okay, maybe at this point it's consistent, but the numbers will be different a bit. And even if we are using fancier approach, so let's provide an asymmetric model. So, oh, I did not get error message. It's good. So I did not mess up the code. Still, we can say that even if the fancier model is used with the asymmetric nature of volatility, nothing is changing dramatically. So 1.3 is less than 1.3, so it's even less crazy. Okay. Yeah. So this is how we can generate possible time series.
If we run it 1,000 times, will that make a difference?
Let's check it. I don't think so that it should be. It just takes longer time. Okay, that was the longer time. Can we see 1.3, 1, it's around really close to 1, and the appreciation is 1.76. It's not perfect, but it's a way to support our work. So let's bring it back to our... Next week we will continue the work here at this forecast, but I prefer it way better than what we can do in Excel, because in Excel we can go here and we can click on it that, oh, it's weekly, and there is data. Yeah, there is somewhere forecast, just forecast sheet, yes. And options. I did a video about this a year ago. We have confidence interval, include forecast statistics. Let's have basic 2. So maybe I should add the date as well. Yeah. Yeah, okay. So forecast will end in the far future. Okay, what happens 5 years later? In 2027, and include forecast statistics. So what do we have here? It says that it's less pessimistic. So if we are comparing it with the simulation said that, oh, it will not depreciate at all, but right now we can see that Excel tells us that it's 1.12, 13, so it will depreciate a bit again. So this is the low of effort approach, that we just hit forecast and that's all. And yeah, this we have to see. So we have two main diagnostics in the case of forecasting. One is always the mean average error, so the MAE, and there is the RMSE. The MAE is always describing the accuracy of the mean. The RMSE is always describing the accuracy of the standard deviation, so how the standard errors are happening around each other. And if we have two models which are competing with each other, then always the model with the smallest May and RMSE number will win. So this is just for selection. Right now, because we have only one model, we cannot decide that it's good or bad because there is no alternate model here. So